And we're live. I feel like we haven't been live in ages, so I'm actually really excited.
No, yeah.
So in this episode, it was actually inspired by Hart. He posted that Across has this new proposal for Cross Prime, and it's the evolution of their protocol to make it more capital efficient for relayers. So we are going to first jump into how a cross protocol works by our understanding, of course, and how intents work, and then talk about this improvement that they are proposing. So definitely watch this if you want to understand the nitty-gritty details.
Yeah. And I posted the link to the Cross Prime in the chat for anybody who's curious.
Awesome.
All right, let's dive in.
So,
So
yeah.
go ahead. All right, so what is an intent? So I think there's a couple of things here. So generally, when people talk about intents, they're referring to intent bridges, which is basically what we're going to talk about on this episode here. I do want to mention that, an intent really could be anything. And I think that this is where the future is going, where it's not just to bridge, but it's also to bridge and do some sort of arbitrary like logic across chain. There's even protocols like Anoma that are just about any intent you can think of. Like it doesn't even have to be related to a token, and it is going to solve it for you. But so maybe that can be in a future episode. But today we're specifically going to focus on intent bridges. So Alicia, what is an intent bridge?
Yeah, I love that explanation, by the way. I need to check out Anoma. And so an intent bridge, it gives you the opportunity to move assets across chain without thinking about the various mechanisms to do so. So right now, if you were to do that, you have to use a bridge. So technically, you're still using another protocol to do intent bridging. However, this time there is someone who's actually fronting you the funds, and they are going to be doing the bridging on the back end, and you don't have to worry about that. So you just say, hey, I would love to see my tokens arrive on, let's say, base chain from Ethereum. And there's someone who's on base who'd say, okay, cool, I'm going to give you those funds on base, and then I will, communicate with the protocol to get my funds back from you. So the user still has to go to a protocol to get this done. It doesn't mean they just imagine bridging and it happens, but it's just less complicated and less decision making on their end, because of course the person who is filling that transaction for you, they're going to use the most efficient way for bridging. Whereas if you are not using an intent bridge, you're probably like, should I use a canonical one? Should I use a third-party bridge? Where do I go?
Yeah, exactly. And like I think a really good thing about intent bridges is that you get native tokens. So this is a big benefit they have over a lot of other bridges in which you get wrapped tokens on the other side.
Yeah.
And native tokens are really great, especially, native like native ETH, because that's the gas token you need on a lot of these chains. And so a wrapped ETH version just isn't going to work for you.
Yeah.
And I would like to point out that an intent bridge is it's a liquidity bridge, which I'll kind of explain what that is. And basically, a liquidity bridge is where the actual native funds aren't really moved very often. They're only rebalanced every once in a while. And what happens is that the native funds don't ever have to move chains. It's just that you put your funds on the source chain, and then someone gives you funds that already exist on the destination chain. And so this is a liquidity bridge. And you can have liquidity bridges that are not intent based, but a vast majority of liquidity bridges are intent based because that's exactly what an intent, bridge is doing.
Yeah. No, I think that's a great mention as well. And I think liquidity bridges, at least the ones I've interacted with in the past, they may have been some aspect of not using a native asset like you mentioned. By the way, if you're confused about native assets versus wrapped assets, we do have an episode about that. So definitely check out our YouTube or Twitter. But yeah, so I think that with using the bridge and the fact that it's a liquidity bridge, it means that someone is fronting you the liquidity, but there is no swapping happening. So you don't have to worry about slippage. And I think that's my favorite thing with using a cross. You don't have to think about slippage because they are actually just fronting you the liquidity on the destination chain. So in some ways, they're kind of lending the assets to you instead of you having to enter a liquidity pool where you swap it. So the mechanics of that definitely makes it a more user-friendly protocol, because even the concept of slippage is something I've only heard about when doing transactions in Web3. So I think the user experience of intent bridges is definitely number one. I can say that now as someone who used to be a canonical bridge girly. Now I'm using
Mhm.
across almost primarily.
Yeah. No, yeah, we talked about this before the episode. Like me too. Because I was always like, oh, I want to use the canonical bridge. I want to be like a real crypto person, but Cross is just really easy, I have to admit.
Yeah.
And it's also really fast. So like that's the other thing about Intents is they're very fast because you don't actually have to wait for either chain to settle to Ethereum or post data to Ethereum.
Yeah.
It's just up to the solver to decide the risk that they want to take. So
Yeah.
once the solver sees that you put money on the source chain, they can release it immediately to you on the destination chain. And
Yeah.
this is actually a really good segue into talking about like the risk of doing that. So the reason that intent-based bridges are very fast is because almost all solvers, which solvers are the ones that fulfill your orders in intent-based bridges, almost all of them rely on sequencer confirmations. So this is right when the rollup sequencer actually publishes a block. You can get that as a confirmation and say, okay, this will eventually be settled on the L1.
Yeah.
And a lot of rollups do this very, very quickly. So, for example, if you're an OP stack rollup, you probably make blocks every 2 seconds. So the solver just has to wait 2 seconds until they see your transaction that you paid into the across bridge, and then they can fulfill you on the destination chain and front you this money. But there is risk to that because nothing is final until it's final on Ethereum. So there could be the case where one of the chains reorgs and the solver then is out of their money. So maybe if we like walk through an example, a user submits money to a cross and then they receive money on the other side, but then the source chain reorgs to a time before the user submitted their money to a cross. And so now the user has their money on both the source chain and they got the solver's money for free on the destination chain. And that's
Yeah.
not good. Um, so so yeah, the kind of like confirmations that solvers are using when they to check that a transaction was really submitted on the source chain, um, like there's risk there. But to also be completely transparent, I think today almost all solvers use sequencer confirmations.
Yeah.
But we can get into that a little bit later, actually.
Yeah.
Um, yeah.
And I think that risk as well that you mentioned that the solvers have is something that the users don't have. And I think that's
Mhm.
also an advantage of using intent bridging from a user perspective. You don't have to worry too, you have to trust the protocol, of course. You have to trust that their smart contracts are secure. So you still have to trust something, but there's not an additional layer of trust. And I think that's why I used to use canonical bridges, because if I trust a layer two, I can trust in a canonical bridge because the security assumptions are the same, right?
Yeah.
So in that case, I'm getting the same security experience, I would say, almost
Mhm.
the same security experience. Whereas if I had to use a third party bridge, I have to check like, was this bridge hacked before? What are the ways I can be hacked? Like, how can this go wrong? So I think that's an additional thing for cross. But as you mentioned, if you're a solver and you're fulfilling transactions, you don't want to fill someone's order and then you don't actually receive the funds. And that can
Mhm.
happen in these rare scenarios where the blockchain reorgs. And I think when you think about security in Web3, these are the rare scenarios that you have to think about. And this is why, companies are working on various security measures, whatever they may be, they get audits, etc. So since we mentioned the fact that you can't have this reorg, maybe we should just briefly touch on the intent lifecycle. So
Yes.
how does a user intent get filled in a protocol like a cross?
Yes. Perfect. So actually, you should explain this because I feel like you have a good explanation for this.
Well, I would say one thing, Across Protocol has great documentation. So anything I'm saying is from their docs, if I remember correctly. But essentially, a user submits an order. So they initiate this order transaction. They go onto the UI. They are quoted, this is a fee that you have to pay for this transaction if you'd like to send this asset to this particular chain. And when they create that transaction, it goes straight to one of their contracts. And this contract will also submit an event or execute or emit, an event, which all of the solvers in the solver network can see, and they can decide if they would like to fill the transaction. If they do fill the transaction, they are filling it on the destination chain. So on the origin chain is where the user has their original funds, but they want to send it to a destination chain. On the destination chain is where the solver is able to fill this transaction for the user. And the solver also has the opportunity to say where they would like to receive their funds, if they would like to receive the user's funds on the origin chain or not. The fees will be lower for the solver if they do receive it on the origin chain. So that probably is what would make the most sense for them, so that they get the most from that transaction. And then finally, there is something called settlement. And settlement is something that the user does not have to worry about, but it's for the solvers. The solver has to now wait for the across protocol to verify that the solver did indeed, pay the user on the destination chain. So in order for them to determine that, they use something called an optimistic oracle called UMA. So UMA protocol actually created a cross protocol. So these are the three steps. So initiate transaction, fill, and settlement. And in the settlement period, it does take a while. It can take hours. It depends on the train. But I know for sure it takes at least an hour for that to occur. And that is not great. Why is that not great? Because during that time, the solver's capital is locked. They use an escrow model for the solvers. So that means the solver has to put up this money, and that money is escrowed, and only until the transaction is verified, they can then have access to it and then use their funds. And then, of course, there are other factors like maybe figuring out which chain should they participate on. So let's say one day all of the activity was on Base, and then Base just dried up and they want to move to Arbitrum, then they'd have to move around their funds. But that's roughly the intent life cycle.
Yeah. And I mean, intents are really great, especially if you're on one of the major rollups or Ethereum, or you're dealing with one of the major tokens. There's no reason that like an intent bridge could not fulfill any chain or any token. But just what we see today is that a lot of the longer tail of chains and tokens aren't supported. And that's just because it's not really worthwhile for a solver to do so. So, for example, if a solver has to keep liquidity of some like random token on, even if it's on a major chain, like most likely there aren't going to be users requesting that liquidity. So they would be better off just like taking that random token, turning it into USDC, and then providing liquidity there. So that is a limitation of intense protocols. It's just the incentives aren't quite there to expand to a lot of chains, or to expand to a lot of tokens. That being said, though, like there are always new chains that Across and other intent protocols are adding. And like I said, there's no technical reason they couldn't support any token and any chain.
Yeah. And I know we complain a lot about how many chains there are. I don't even know what the number is at this point. But in order for a chain to be competitive, they need to be able to attract users. To attract users, they have to attract developers, and there needs to be liquidity floating around so that incentives can be given. So it is really difficult if you are a new chain and you genuinely have a new proposition that could make things better, but no one can bridge to your chain. I think Across has a really great bridge support, maybe because the protocol is easy to integrate with, but it's still important for us to be able to support the long tail of chains, as you mentioned. And there was this term that was in the Across Prime document. It was called capital efficiency. And I don't have much familiarity with the term. One person at Espresso mentioned that to us recently, capital efficiency. And I was like, oh, I love the term and I would love to learn more about it. And the way that it was proposed in this document, as far as I remember, is that capital efficiency is the idea that you want to make sure that the solver, which is one part of the participants or one actor section that you have, the solver is able to get the most out of their money, essentially. Actually, that's what it is. Get the most out of your money. So it depends on which person you are, what role you represent, is how you will get the most out of your money. So if you're a solver, if you can use your money to fulfill many transactions, and each time you fulfill a transaction, you earn a tiny bit of a fee, then that's a way of being capital efficient, because that one chunk of capital, whether you have $500, $10,000, is being able to perform multiple times in the protocol. And I think for a user is being able to perform a transaction without having to get large fees. So let's say you could swap 5 ETH from one chain to the next and you pay 0 fees. That would be the most capital efficiency scenario for that person. So have you come across that term before, capital efficiency? And what do you think about Across's solution for it?
Yeah, so I have come across that term before. I think like the actual definition people disagree on. It's one of those, just like in crypto, everybody disagrees on the definition of everything. But I think that so Across Prime, which is this new protocol that they proposed, um, is claimed to be more capitally efficient. And yes, I completely think that that's the case. So maybe we could walk through like the solver's perspective on the current Across protocol, and then what it would look like on their Across Prime protocol.
Yeah.
So on the current protocol, the solver they have a user that has some sort of intent, and then the solver fills it and they give the user this money. Well, the user can't access that money that they're owed, that they fronted the user, the until settlement happens, which, like Alicia, you said, could take a couple of hours. So during those couple of hours, the the solver owns that liquidity. Like, they have the right to it, but they can't do anything with it. It's just sitting there. And so this is kind of capitally inefficient. And what would be better is if the solver could get their liquidity back to them right away, and then they could immediately fill another user. So, for example, let's say you're a solver and you have 1,000 USDC, and you get a user that asks you to bridge 1,000 USDC to another chain. Well, now you can't fill any other user until settlement happens, which takes several hours. But you want to, because there's a ton of other users that also want to bridge USDC. And so this is what Across Prime, their kind of new design, fixes, which is basically the solver can get paid right away. So the user will pay the solver in their funds directly, and now the solver can just immediately reuse those funds to fulfill other intents. So in our scenario, instead of having to wait hours to get their $1,000 to get access to it, they can just immediately now fulfill another user's $1,000 intent within like a couple of other seconds. And so that's way more valuable for solvers, because now they can earn way more fees on the same amount of liquidity. So instead of earning only one fee per hour on 1,000 USDC, now maybe they can earn like 50 transaction fees per hour on that same 1,000 USDC. So it's much, much better. And the way that this works across this new protocol is that they have this idea of bonds. So you still don't want the solver to be able to steal funds. And so what you don't want is for the user to pay the solver, and then the solver just never actually fulfills the intent, and then they just like take the user's money. That's not what you want. So what Across Prime does is that the solvers have to put up a bond of some amount of money, and basically this bond is the limit to how many like the value of bridge transactions that they can do at any single time, or that they can have in flight at any single time. So, for example, if we have our situation with 1,000 USDC, the solver might put up a bond for 1,000 USDC. And when they fulfill an intent on the other chain, they can, sorry, let me re-explain this. So they have a bond for 1,000 USDC. And so if the solver fulfills the intent on the destination chain, like, that's fine, and then they can immediately fill another one. But let's say the solver doesn't fill on the destination chain. Well, then they can basically be slashed this bond. So they lose their $1,000, but also the Across protocol enforces that they haven't done any additional bridges. So like, the solver can't have $2,000 worth of bridge transactions in flight at a single time, because they only have $1,000 worth of this bond locked up. So that's kind of the general gist of what Across Prime does. And we can maybe go into a little bit more detail how it works.
Yeah, I think that explained it really well, to be honest. This is something that's not implemented yet. So currently they still have the escrow model, but what Ellie said makes sense. Like, as soon as they're able to fill a transaction, they're able to reuse the bond amount. So if the bond amount they have is like $1,000, then at max they can fulfill, I guess, $1,000, but they can't do more than that within 1 or 2 blocks. But they can later fill another transaction, let's say 2 blocks later. Whereas in the previous model, they would have had that $1,000 completely locked up until the settlement oracle decided whether or not the transaction did actually happen, which would have been hours later. So if you genuinely only have $1,000 to supply to a cross protocol, obviously that wouldn't be great. So it makes it so that more users can be served, which I'm sure would make things more competitive as well at Across. The fees probably would be less variable too. So for the most part, like, when reading this document, I was like, oh, okay, so this is something that helps the solvers more necessarily than the users, at least directly, but it does have, consequences, which is the users will have a better experience because more can be transacted. And it probably will attract more solvers as well to a cross
Mhm.
protocol, especially on whether big chains or even smaller chains, because you don't
Yeah.
have to put up a lot and you could potentially earn a lot if the chain has a lot of activity. So I think that was a very impressive, I guess, design change. It would not have been the design change I would have thought they would have been doing immediately. So it really made me think like, oh wow, like as a cross protocol solve in their community, they really understand that their first users, or at least the ones who can make the biggest change in their protocol, are the solvers. And I think that was like the biggest learning for me when I read this document, because I was like, oh,
Mhm.
I would think they would try to solve for something else. I don't know what, because it is quite fast, it is quite cheap. So they're actually doing a good job on the user front. But yeah.
Yeah, I think, and I thought it was really interesting how they solve this because like I said the whole point of this is that the solver can just get paid directly by the user. But then obviously the question is like, well, okay, well, how do you actually like enforce that? Like, how do you enforce that the solver actually does
Yeah.
fulfill the transaction on the other side if you don't have any sort of like settlement to prove that they did? And I think this is really interesting where, at least as far as I understand their paper, they basically kind of rely on the user. So the user, before you submit a transaction, the user can check how much that like that solver has in flight,
Okay.
and they can see then how much, like the limit to what they can bridge. And the way that this works is that there are two Merkle trees on each chain, the source and the destination chain. Um, and every time like a user submits funds or submits an order to a solver, like a new leaf is added to this Merkle tree. And so the Merkle, um, yeah, it's added to this Merkle tree.
Hmm.
And then when the intent is fulfilled on the destination chain, the same leaf is added to the Merkle tree. So when the two Merkle trees across the chains are equal, then you know that the solver shouldn't have any money in flight. But if they're not equal and the one on the source chain has like more leaves, then you know that the solver has like that much money in flight, based on whatever the value of those leaves are. And anyway, it's like a really clever solution because you don't like you still need settlement at some like to some extent to rebalance, but you're really saying like the user is incentivized to make sure that these Merkle trees match because otherwise they could lose their funds. But you don't actually have to have like cross-chain communication and confirmation, but with like a whole protocol in between it though, which is it's very like clever. You kind of making everything like incentive compatible so that people who are incentive to check that the bridge or that the solver doesn't have much in flight are like
Yeah.
able to do that.
Yeah.
And I mean, as I understand it, there's also like smart contract enforcement of these things as well. But um but yeah, that's how it works. And I think this is a really neat thing I think about this is, so we kind of mentioned earlier that a lot of the solvers use sequencer confirmations when they fulfill orders.
Mhm.
And that's totally true. They can still do that with across prime. But at least as I understand it, I think an interesting thing is that now it gives the user the choice of like which confirmation they want to trust. So if a user wants to trust the sequencer confirmation, maybe they see that the solver only has $1,000 in flight because the
Yeah.
sequencer confirmation said um, that, oh, these are the values of the Merkle trees and this is the difference. But maybe the user says, I don't want to trust that. And so they wait for a stronger confirmation. Now then the
Interesting.
user might see a bigger difference, right? Like now the user might see, oh, this solver has like $10,000 in flight that haven't been actually settled on the destination chain. And then the user can make their choice based on that. And so I really, really like it because it actually gives, instead of only needing to rely, well, I guess to clarify, the user is never at risk in the
Mm.
current across
Okay.
protocol right now either. But I like that you can have this model of like the user gets to enforce which kind of confirmation they think is secure and which kind of confirmation they listen to when they determine like how much money a solver has in flight. And I just think that that's really neat. Obviously, with also being a confirmation network, we're very into confirmations. So
Yeah.
yeah.
Interesting. I actually didn't clock that about it. I didn't realize the user had the ability to check that. So I need to read into that a bit more to understand it because I know they're going to come up with a really nice way to do that for the user too, since it is a very
Mhm.
user friendly protocol. I just saw that I actually did reply to the tweet from Hart on Twitter. And I was asking what other improvements do relayers need? And Hart replied and he said relayers need better rebalancing options between chains, aka native ways to move tokens around.
Yeah.
So that was interesting to me. I didn't reply. I should have. I didn't see the reply. But like you would think they would just use a cross protocol.
Yeah. No, so you're totally right. Like, I thought this blew my mind. I was, talking to someone who's, like, very familiar with all of this intense stuff, and, they did say that sometimes solvers use intents to rebalance for themselves.
Yeah.
Like, and it's actually kinda wild because I guess from my perspective, I thought, well, of course, they couldn't use that because, like, at the end of the day, someone has to actually, like, move these funds from one place to the other. But
Right.
depending on what you're trying to rebalance, maybe you can
Yeah.
just use a solver to, like, settle your solver or bridge, yeah,
It's like,
but
bro,
at
just
the
give me a good fee.
yeah, exactly. But at the end of the day, yes, you need to, like, actually move native funds and, or sorry, like, yeah, real funds, and right now
Yeah.
that's really slow because you generally well, almost always, you have to use a canonical bridge, which might have, like, a 7-day withdrawal period if it's an optimistic rollup
Mm.
or even still, you just have to wait for it to finalize on the L1, the very least, which takes at least 15 minutes.
Yeah.
So, yeah, it's very slow. So, if you could have ways to make native bridging a lot faster,
Yeah.
then that could help. Well, help solvers rebalance their funds.
Mm. As I think about it live, I reckon one of the reasons why they need native bridging for rebalancing versus an intent bridge is the fact that they're probably rebalancing a large amount of funds. And therefore, the protocols don't, like, most relayers are not willing to do that kind of cross chain transaction. So they actually need to use a native bridge where there is no limit. Of course, it
Mhm,
takes longer, but this is their business. This is how they make money. So they're willing to wait the time. But of course, the faster they can do it, the better. And just to explain why rebalancing is necessary, imagine if you started off thinking, okay, I noticed that there's a lot of bridging from Ethereum to Arbitrum. So then you're going to make sure you have funds on Arbitrum so that when the user is requesting that transaction, you can, give them the funds. Now, if all of your money is now on Arbitrum because everyone is like, hey, I love the fact that you're solving, well done, and they're able to
mhm,
swap across to Arbitrum, then now you're like, oh, shoot, but people are just staying on Arbitrum and I don't have a lot of bridge transactions to do. So they need to be able to take their assets back onto Ethereum or whichever route they think would be, the most profitable. So that's why as a relayer, they themselves are probably one of the highest users of bridges because they have to also
mhm.
like get their funds to different places too.
Yeah. And I wanted to go back to another point about capital efficiency, which
Yeah.
is where ultimately any liquidity provider is going to go where they get the most yield
Hmm.
for a certain amount of risk, obviously, because with more yield comes more risk. But I mean, I don't think Across has any issue attracting liquidity, but this like a thing you do need to think about is that this basically in theory, should boost the yield that all of the solvers are making on their liquidity, which then might attract even more liquidity. And the more liquidity you have in a liquidity bridge, like the more efficient it is, the better for users. So, um, anyway, yeah, I just overall I think it's a really neat idea. It's like
Yeah.
Across Prime is just like really clever because it it doesn't actually require like hardcore cross chain communication.
Yeah.
Yeah.
Yeah, I agree. And as you mentioned, yield, I wish I knew how much yield a relayer makes. And actually, when I saw capital efficiency on this doc, I'm like, okay, yeah, you're going to make it so that they can earn more from the transactions. But surely trading more means you earn more, or like filling more intents mean you earn more. But it's not clear how much they earn because it is a competition as who can do this the fastest.
Mhm.
So yeah, I would love to learn how it works from a relayer's perspective. Like, is it just sometimes you're able to fill, sometimes you don't, and then you just earn the fee, and that's how it is. That's the game.
Yeah. Mhm. Well, yeah, that's an interesting thing about intents in general is that there's a lot of so only one solver can fulfill your order. But
Mhm.
there's a lot of solvers that might be able to, and so they have to compete with each other to
Yeah,
see who can fill it the fastest, or maybe who can fill it for the cheapest. And so
yeah,
it's really giving the user like the best benefit because you're having all of the solvers compete to give you the best user experience. And
100%.
intents are here. I really love intents. Like I feel like this is just a shill, but no, I actually like intents are
100%. We
totally the
are
future.
intense. Well, yeah.
Yeah.
We're intentional about intense.
Mhm.
I think that okay, one thing I saw on their website, right? You can when you're specifying, like normally a user wouldn't do this, but if you're a developer creating a UI, you can specify like which solver you would like to fill a transaction. So let's say we're like, oh, we love intents. We would love to create an intent bridge, which is using a cross protocol underneath the hood, but we have our own page for swapping. But let's say we also have our own solver. We can then say, okay, everyone who's using our bridge is also going to be using our solver. So at least like even though across protocol they have their own, system, they have made it very programmatic and made it easy for developers to integrate with it. So there are ways that you can say, I only want to have this solver solve my transactions. Of course, if you're doing that, you have to be very confident that that solver has high uptime, etc. But it still is an option if you decide to go that way.
Mhm. And all right, this wasn't on our plan, but maybe
Mm.
now I briefly want to mention ERC 7683. So this
Oh.
is like a crosses and Uniswap's ERC, and I feel like it's very popular. Like you see it get mentioned a lot, although it's hard to keep track of all of the ERC numbers. But basically, what ERC 7683 does is it kind of like standardizes the messages that solvers use to like send things across chain.
Right.
And the specific reason is that this is very good, or one of the reasons is that you might be one solver, but maybe you want to participate in like multiple solver networks because maybe a cross is deployed on some chains and then like another intent protocol is deployed on others. If they all use like the same message type, then it's really easy for you just to plug into like any protocol. And what that means is that it's like a lot easier for solvers to provide liquidity on different chains. Like if they see that, oh, this chain is now in demand, they can maybe get their liquidity over there much more quickly rather than
Yeah.
having to like, spin up an entire new infrastructure that uses something completely different. Um, and then the other benefit of 7683, which is also in line with something called the Open Intents Framework,
Hmm.
is basically to make intent solving very modular so that, all of the different pieces fit together. So, you don't have like just a cross as the only intent protocol that can exist, even though it's a wonderful protocol. But yeah.
Yeah, that's a great mention. Thank you so much for bringing that up. Even though we're talking about intent bridging and across protocol,
Mhm.
there are other protocols that do offer intent bridging, and I reckon they
Yeah.
follow a similar life cycle too. I just went to their documentation on Across Prime, and they do have a section about ERC 7683 compatibility. And they said it was authored with the escrowed intent model in mind. So this is the current
Mhm.
model that they have.
Yeah.
But this new model across Prime is generally compatible with 7683 as well. So seems like they definitely are planning to, make it extensible in that sense.
Mhm.
One thing I saw in their docs that was interesting. I hadn't seen the term before, but it was capital asset maxi, like being a capital asset maxi. Oh, no,
Mhm.
wait. Is it capital asset? Wait, let me check what exactly it was. Canonical, sorry. Canonical asset maxi. And I've never heard that term before because when you think about maxis, you think about being a Bitcoin maxi, for
Yeah.
example. And I realized from the episode that we had about Raptor versus canonical assets, I'm definitely a canonical asset maxi.
Yeah. Yeah.
And one thing about intent bridging that is very useful is the fact that you do use canonical assets for bridging. And in their documentation, they mentioned something which I thought was interesting. They said the verification method used is precisely what distinguishes canonical versus representative assets. So I know we have a previous episode on that, but essentially with a canonical asset, you have like, okay, if you're using Arbitrum, for example, they have that very much enshrined into the protocol, the way that, the cross-chain bridging works. Whereas if you have a third-party solution, for example, if you're using layer 0 or Hyperlane, you may have to create a representation of that token that you're trying to transfer. So one thing that we really highlighted about intents at the beginning of this episode is the fact that when you're bridging, you're receiving the native asset. So you don't have to worry about losing any capital due to fees or anything like that, or having to unwrap the token. But one thing that Across, as far as I know, does not support is NFT bridging.
Yeah.
So, like, like currently, is there a concept of a representative NFT? Like, I know Ellie, you
Mhm.
have some thoughts on this. So
Yes, I do. So I've like I like the future of NFT bridging. It's really not popular to bridge NFTs today, but I think
yeah,
partially that's just because it's very difficult to do. I think in the future you can have these like really cool NFTs that you can move around to each chain and they can be great. But so the reason that any sort of like liquidity bridge of which across is one cannot support NFT bridging is because by definition of an NFT, there's only one of them. So how do you have liquidity on like the other chain of this NFT when only one exists? So if you want NFT bridging, assuming you have some NFT that like has a very low, like there is only one or two of them, um, then you need to do native bridging. You need to actually mint and burn the NFT across chains. And so this is why like no liquidity bridge can basically do this. In theory, you could make a wrapped NFT, and I'm sure that that exists somewhere. But
yeah,
just like we talked about how wrapped tokens aren't the same as their underlying tokens, like it's the same goes for an NFT. It's not going to ever be like the same canonical representation of the true NFT. So, yeah, so to bridge NFTs, you need like if you wanted to bridge NFTs today, you would have to go through the Rollups canonical bridge, which usually is going to take like 7 days at minimum. And so yeah, but I think in the future, there's things that exist to make this a lot faster. And I think once that you can kind of natively bridge NFTs across chains, I think that we'll have a lot of really interesting use cases pop up.
yeah. Yeah, that's interesting. I think I saw on Layer Zero you could create like a wrapped version of an NFT for bridging. I didn't even know it was possible to do native bridging with NFTs currently.
Yeah, I think so. Yeah, it is technically possible. I just don't think anybody does it.
Yeah. Like it depends, right? Like why would a protocol have the incentive to do that? But I guess if they
Mhm,
wanted to do it, they would just need to have they would just make it just like a regular bridge, whether it's like lock
mhm,
and mint or burn and mint, but they'd have a contract that you interact with on the origin chain. Something happens, let's say it gets locked. They have something off chain that's verifying that, whether it's the Oracle or some other network. And then
mhm,
it gets minted by, of course, I want to say the canonical contract on the
mhm.
destination chain. And like even like for a use case for this, like I know we can't even think of use cases, but like I was just thinking like, you know how banks sell loans and like
Mhm.
somebody else like now owns your loan and now you're paying
Yeah.
someone else. Like maybe
Mhm,
that could be seen as, something for NFT bridging where the loan itself is an NFT and someone can buy that loan. It might not be on the same chain. Or let's say you're trying to repay a loan. Let's say you have a loan on Aave and you have that loan on Ethereum, gas fees are bonkers. You would love to pay back the loan, but the gas fees are so high. So you then bridge it to another platform that supports Aave, bridge the loan itself.
mhm.
Hmm. I mean, technically, you can't actually do that right now. It doesn't need to be an NFT, but you catch my drift.
Yeah. No, I really love the idea of like a loan because like no, that's like you're totally right. That's exactly what happens today is like, banks buy loans from other banks and yeah, it's like that's like yeah, a really cool thing.
Yeah.
The other thing
So,
I feel like I want personally out of it is that I kind of just want all my NFTs on one chain.
mm,
Like it's kind of just annoying to have to keep track of like where my NFTs are across all of these different chains, which address they're associated with. Yeah, I would just like them to all be in one place, which you
yeah.
can do with native NFT bridging.
Yeah. I would say though, if your NFTs are all on one chain and your NFTs serve a specific purpose, let's say NFT is actually like a game element, but the game is not on
Mhm.
that chain, then you would need to also have composable contracts across chains for that to
Yeah.
make it more beneficial. Because then even if all your NFTs are on Ethereum, because you're like, you know what, I trust Ethereum most, you can still interact with the game that is on Polygon or Base. So contract composability is important, guys. So I think we covered everything. I mean, there was a topic that was mentioned on the docs that also I wasn't familiar with. I think it was called fair exchange.
Oh, yes.
So do you have insights into that? Do you want to touch on that?
Yes, I would love to touch on that. So fair exchange is like a really common problem that you run into in distributed systems.
Mm,
And basically, it's how do you guarantee a fair exchange? If you're like if Alicia and I are exchanging money and we don't trust each other, how do we do it in a way that we either both get our money or like, if I'm paying you for some NFT, how do we transfer that money in a way that you definitely get paid and I definitely get the NFT, or none of it happens at all? Because like let's say I say, okay, I'll pay Alicia first, and then Alicia just never transfers me the NFT, and then now I'm out of my money. So
Mhm.
this is the fair exchange problem, is how do you get a fair exchange in some sort of decentralized system where you don't trust the parties that are involved? And this shows up all over the place. Like even outside intents, it shows up in consensus protocols, etc. And so there's actually um like you can prove that it's actually impossible to do a fair exchange if you don't have like a trusted third party and you're in like this um, decentralized network. So basically, if you're not willing to trust some sort of party and you want to do a fair exchange within a certain time period,
Mhm.
it's impossible. That's like actually provably true. And the reason is
Interesting.
is because like let's say I say, okay, I want to do this trade with Alicia within an hour. Well, at some point, one of us could always just wait the timeout and not complete our section. So if you assume that the other side is going to like be live and will actually participate in the protocol, then you can do it. But if you don't trust them already, you probably aren't going to trust them to be live. So that's like the thing. And so we have to do a lot of these like really clever solutions to get around it. And that's what Across is doing today in their current escrow model, but also in this Across Prime model. So today in their escrow model, the fair exchange is between the user and the solver for funds. And so the fair exchange is done in a way where that's why you have this whole settlement mechanism at the end, because you don't want the solver to be able to run off with the user's funds.
Right.
But then you also don't want for some reason the user to be able to run off with the solver's funds either. But it's important to note that like there's still some assumptions in here. So like the technically in a solver network, the solver is still at risk. Like you could imagine some weird edge case scenario where for some reason their transaction that proved that they fulfilled the user's funds like was getting censored from the chain, then they never will like be able to reclaim their funds. So from a theoretical perspective, you haven't solved the fair exchange problem, but you've solved it in a practical sense, because you're going to assume that eventually the solver can like submit proof that they fulfilled their transaction for the relayer. Um, and then the way it's done in Across Prime is through this kind of like slashing bond
Yeah.
mechanism, where if the solver does not complete the fair exchange, then they get, this bond slashed. But you actually also have the same problem though. If for some reason, there was no way that the solver could prove that they fulfilled the transaction because like they were getting censored or the chain was down, it is possible that they could, then not ever be able to reclaim their funds. But mostly that's just like a theoretical problem. And it's like a
Right.
really interesting distributed systems problem. But in practice, it's totally solvable. But uh, anyway, yeah. So like the fair exchange problem is like, how do I exchange something with someone who I do not trust at all
Yeah.
in a way that like benefits, make sure I'm safe and make sure that they are safe too.
Awesome. That was explained so beautifully. Thank you so much for that. And like I saw it in the docs, I was like, fair exchange problem. I'm like, why are we making up terms now? So I didn't know it was a distributed system problem.
Yeah,
But
it's such
that's
a
great.
yeah, it's such a distributed systems thing. Oh, if I can do like a really interesting side note, there is a way where you practically solve this problem. It doesn't solve it in theory, but basically what you do is you have each party reveal one bit at a time and you go back
Mm,
and forth. And then the idea is that if if one party just like stops halfway through the protocol, well, then they don't have enough information to actually figure out the data you were sending them.
right.
But if they stop at the very last bit and they don't give you the last bit, you have enough information to like probabilistically figure out what they were sending you.
Yeah.
So yeah, it's like a practical way. I don't know. It's kind of weird. Like you think of exchanging bit by bit like 1,000 times, you know,
Yeah,
to like send some NFT, but it's a
that's
I
crazy.
really think it's an interesting topic.
I always wondered as well if across protocol supports partial fills and if there'll be any incentive to. But as part of the intent lifecycle, there is something called a slow fill. So if for some reason your transaction is taking a while to be filled, you can submit another transaction which enables this slow fill. And that means eventually someone will solve it because, or will actually fulfill the intent. Because when you specify an intent transaction, there's normally a deadline.
Mhm.
And in the odd scenario where no one fills your transaction, you're able to claim your funds. So that's the good thing about interacting with Across as well, that majority of the time the transaction will get filled, but if not, you can just go and claim it. Of course, for a user, that's not the best experience, but it's definitely them, preparing for, some edge cases.
Mhm. All right. Yeah, I think we've covered almost everything that we wanted to talk about.
Yeah.
Mhm. All right, so maybe to wrap up, are intents the future or are they just a stopgap? So you could say, some people might say yes, intents are the future, and I would probably agree with that. But other people, you could say, well, this is just a stopgap because we don't have better interoperability. Like ideally, interoperability would be able to happen without this like solver entity at all, and the chain should just be able to directly communicate with each other and verify with each other. So yeah, that's the question to the audience. Are intents the future or are they a stopgap? In my opinion, intents are the future. I do think we definitely need a lot better native interoperability, but I think this idea of an intent where the user just says, I want this, go figure out how to do it for me, is a really good model. And we need that.
Yeah.
And maybe in the future, like these intents are actually solved like partially by a solver and then partially by native interop as well. So you could imagine if you have some really sort of fast canonical bridge, well, maybe that's just what it does for the user. Is it just sends it through the canonical bridge that only takes 5 seconds. But I think in the future we'll always have some notion of an intent, and we'll always have some notion of some solver that has to like figure out how to solve the intent. So anyway, I think they'll be an important part of the future for sure. But what do you think, Alicia?
Yeah, I think intents are the present and the future. I
Mhm.
think that it works today, it works very well right now, and that's beautiful. And I think there's always need for someone to do a transaction on your behalf, like third party, middlemen, all these things exist in the real world. But the good
Yeah.
thing about the blockchain space is that it happens programmatically. So you don't have to think about too much and it can happen in a very fast time. So I think that's the benefit of using intents. So I think even if we were to have faster interoperability, let's say for whatever reason, canonical bridges are now just as fast as intent bridging. Perhaps if they don't work on their UI and they keep it the same as it is right now, people will still go to a cross protocol
Mhm.
because there is that competition as well. So yeah, I think intent bridging is really great. Of course, when we talk about intent bridging, it's all about asynchronous composability. If the desire for synchronous composability grows, and of course, intent bridging will not be the best solution for as the way it stands right now. But I think in those scenarios is where we'll see more deviations. But I think the need for intents in general makes sense just so that you can create more seamless applications for the user.
Yeah, totally agree.
Yay.
All right, let us know your thoughts if you think intents are for real or if intents are even real and if they are the future or if they're just like a temporary stopgap. Let us know.
Awesome. See you in the next one.
All
Bye.
right. Bye, everybody.